Alright, so in this video I want to introduce briefly a topic that we're going to be talking about throughout all of linear algebra. This is really part of the bread and butter of linear algebra, and that is what is called a linear combination. So I want to go ahead and give just a brief definition and an example of that mathematically here. And then in the next video what I'll do is I'll actually connect this idea of linear combinations to something we've already discussed a little bit. So say I have a set of vectors v1, v2, all the way to vp, alright, and these vectors are in Rn, and I have a set of scalars c1, c2, cp that are real numbers. Okay, so these are just in the real numbers. All right. So before I go on and define a linear combination, what I want to make clear really quickly is this idea of what these vectors kind of look like. All right. So we have a set of p vectors. So we have a set of p vectors, right? Where p is some positive number, right? So it defines the length of the set, the number of vectors we have, right? Equals number of vectors. Okay. And the n in Rn is what defines the number of elements in each one of these vectors. So v1 could look something like this. All right, so v1 could have, I'll say entry 1, entry 2, all the way down to entry n. Okay, so that's what these vectors really look like. All right, so there is a positive p number of n entry of vectors, or n by 1 vectors. Okay. All right, so now let me define a linear combination. So another vector y defined by v1, I'll actually go ahead and write it. I'll write the weight first because that's the kind of notation we'll be using throughout. v1 c1 v1 plus c2 v2 plus and dot 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 and then another plus cp vp, okay, is called a linear combination, right? So this right here is called a linear combination of the vectors v1, v2 through vp, right? So this is a linear combination of the vectors v1 through vp with weights c1, c2 through cp. Okay, and take a minute to think about what this really means, what we're really doing here, right? We're coming up with some new vector y using vectors that we have in our set and using a certain weighting mechanism, a certain weighting set, right? So these c's are a set of numbers, a set of scalars, right? A set of scalars or weights, and they're acting upon this set of vectors v1 through vp, and in that process we're ending up with a new vector y. Okay, and this is something that we'll see throughout this entire book. This is the fundamental part of linear algebra that we'll see time and time again. And in the next video, I will go ahead and actually connect this idea of linear combinations to things that we've already done, and the two fundamental questions that we ask ourselves when we look at problems and systems of equations in linear algebra.